Hello and welcome once again to Physicsify. We are still doing vectors. We are now into the part 12, and guess what? As I told you, as I promised that we would be doing direction of the resultant now. Here we go with the direction. Now, last session things were a little difficult. So let us quickly have a revision of what we did previously. We actually tried to get the resultant and the magnitude came out through this formula where we just need the vectors and the angle between them to get the magnitude of resultant. But that's not all. If you want to get the resultant vector as it is, not only do you need the magnitude, but you also require the direction. So that is what we would be trying to do today. Let's start this up. So what we'll say is that if we are to get the direction of the resultant, we are first of all defining certain angles, right? One of the angles I'm defining as alpha, this is this angle, that is the angle between vector r and vector a. Another angle that I'm defining is beta, that is between vector r and vector b. So we want to get both these angles because you never know. Resultant might be asked with respect to A, it might be asked with respect to B. That the angle between R and B or the angle between R and A, anything would be asked to you. But don't worry, we're going to cover both of them today. So what will I say next? I will first of all say that we knew this formula r square equal a square plus b square plus 2ab cos theta. So the next thing I can say is that magnitude of r turns out to be under root of a square plus b square plus 2ab cos theta. Something we have already known. Can we get this angle alpha now through something? I think you already know. You already remember this triangle. This triangle can actually help you get alpha. Let us say we wanted to get this. So I will say, first of all, please remember that this theta would be between 0 to pi, right? This angle, we have already defined this earlier. Way back when we studied angle between vectors, we said that the angle between any two vectors can only be between 0 degree to 180 degree. This is what we are saying earlier. But the next thing that we are drawing out is that in this triangle OXY, again this triangle that I'm talking about, I can write tan of alpha as perpendicular by base. So I will say that if I consider this triangle OXY, that is this triangle over here, I was saying this angle is alpha. So the next thing that I can draw out is that tan alpha would be xy divided by oy, that is perpendicular divided by base. And this perpendicular, if you remember from this triangle, this xy was b sine theta, right? So this length is b sine theta as is written over here. And similarly, this zy length was b sine theta. So full OY would be a plus b sine theta. If this is a, this much length was b sine theta. This one length was b cos theta. So now I can write in place of OY, in place of this length, a plus b sine, a plus, I'm really sorry, this is b cos theta and this is b sine theta. So what probably we get is that this perpendicular xy is given as b sine theta, xy as b sine theta, and this much length, that is zy, this came out to be b cos theta. This much length is b cos theta. So a plus b cos theta becomes oy, that is written over here. And from here, you are actually getting the required angle. How? You can just say alpha is now tan inverse of all this big thing that has come, that is b sine theta divided by a plus b cos theta. So you have gotten this alpha, but remember one thing, this angle is only with respect to vector a. This is not with respect to vector b, right? Another thing that you can probably do, sort of your homework, you can also write sine of alpha as perpendicular by hypotenuse. So just in case I wanted to write sine of alpha, I will say this is b sine theta divided by magnitude of r. Similarly, you can write cos alpha, you can write cot alpha, you can write cosec alpha, you can write sec alpha. But the most commonly used thing happens to be tan. So that's why I have written that down. Okay. Now this was all with respect to a vector. It could be with respect to b vector. So what will you do then? All these things remain same initially, right? The magnitude, the angle between the vectors, it's same. What's the new thing now? That if you were actually extending A and then putting a perpendicular from the head of the resultant, this time around, if you want to get beta, you would like to extend B and put a perpendicular like this. So that is exactly what I have done over here. This is obviously your B vector over here. This has been taken extended, and there is another perpendicular being drawn from this point X where this is your R vector. And if you see, I think you can always say that this angle is going to be theta. If you want to define, you can say this length is actually A vector. So this will become A cos theta, and this much length is going to become A sin theta. What's the next thing that you can do? You can say that now tan beta means if I take this triangle, tan of beta, that is this angle, is perpendicular, that is A sin theta divided by base. Base would be B plus A cos theta, that is written over here. So now you can get beta as tan inverse of A sin theta divided by B plus A cos theta. So you can get any angle. Again, if you want, you can get the sin beta, you can get the cos beta, you can get any types of beta. That actually depends what is given in the question. Mostly we would be considering an objective question. So in that case, the options are written. If it is in tan inverse, go with tan. If it is in sin inverse, go with sin. If it is in cos inverse, go with cos. But if it is a subjective question, you can go ahead with this way. You have defined one of the angles in tan inverse. You can do it in sin inverse. You can do it in cos inverse. But the bottom line is that you should get that angle, right? Again, this was with respect to B. And I hope that now you know full analytical method of calculating the resultant vector with not only its magnitude, but also its angle, right? This was all that we had for today. Ciao ciao for now. In case you loved this class, please make sure you like and share, and you can subscribe to never miss a notification. See you in the next class later.